Now let's look into the one more tool that we have in our pipeline. So far we have seen the hard way of setting up our Kubernetes cluster. Then we set up a cluster using Docker Desktop and its Kubernetes extension with the help of kubectl. And we have we used Minikube to set up the cluster, and we have deployed an application inside that single node Minikube cluster. So now it's time to think big. It's time to do big. We are gonna do big with COPS. So a COPS, a multi-node Kubernetes cluster on AWS. We are going to create a multi-node Kubernetes cluster on AWS. So here in hands-on COPS, we will use COPS tool to create a 3-node cluster, a Kubernetes cluster, and inside that we are going to do 3 to 4 exercises such as deploying various applications, various stateful applications, stateless application, and simple hello Kubernetes applications. We are going to do all those things. Simply to say, fun is loading. Okay, so let's write prerequisites for the same. So working with the COPS, in COPS we will begin with the prerequisites, prereqs. So the main prerequisite is you should have AWS account with root user access. Okay, then after that we will begin our work with creating our cluster. Then we will follow step by step. So the first step is to create a Kubernetes a cluster to make our hands dirty. So to do all the experimentations on various Kubernetes objects, we require a cluster, a Kubernetes cluster. So that's what we are going to do here. So we are going to create a Kubernetes cluster using COPS and Amazon Web Services. So how do we do it? So to create a Kubernetes cluster, the first step is we need a domain for Kubernetes DNS records. So I have my domain imlike.com from GoDaddy. So you also have to create your own. Then once that is done, we have to create a Linux virtual machine and setup. So here I'm going to use EC2 instance, and inside that EC2 instance we have to install COPS, kubectl, SSH keys, and AWS CLI. Then we have to log into that AWS account, and we have to set up S3 bucket. I am user for AWS CLI Route 53 hosted zone. S3 bucket is to store the state of the objects. Then final step, log into domain registrar to cross check. And once we log into the domain registrar, you have to create NS records for subdomain pointing to Route 53 hosted zone NS servers. So naming servers basically. So naming this NS servers should be a Route 53 hosted zone NS server should be connected with the NS records of the subdomain, so that the EC2 instances which are part of the AWS can be put into the domain of subdomain of GoDaddy, so that we can access these EC2 instances through the domain names using naming server. So let me put these activities into our sticky note, and this is Kubernetes in action. So the first exercise in this is to create a Kubernetes cluster using kops. So first what we are going to do is we will open GoDaddy and we will create our domain. Then as usual AWS EC2 instance T2 medium. I'm gonna go with T2 medium, and once that is done we will also create S3 bucket IAM user and route 53 hosted zone. And once this is done, so we will log into our domain registrar, that's a GoDaddy, and then we will point out the route 53, or a simple way we'll make connection between route 53 hosted zone NS servers and GoDaddy or our domain. Okay, connection. Okay, so these are all steps for now. Then we will proceed further. Once these are all done, we will proceed further. So for that, first we will get into our GoDaddy account if you have one, or else you have to create one account. So let me get into this. This is my AWS instance, and first let me log into GoDaddy. Login. If you do not have, you have to sign up. If you have an account, you can sign in. So I have my account, I have signed in. So now here type the domain you want. So I have my domain imlike.com. If you want to create a new domain like cherry tails, this could be the start of something. So you can find out some cherrytails.com, cherrytails.in. So a lot of .co.in, .co, .tv, .shop, .club. So a lot of domains are given. So this is exact match. So if you want to buy it, you have to click it, make it yours. Then you have to continue to the cart, and then you have to pay money. It's 139 rupees for the first year with a 3-year registration. Okay. However, I have my domain, so I'm not going to go with that. So I will use my domain itself. Okay. You have to create your own domain if you do not have. So my domain is imlike.com, because my domain belongs to machine learning and artificial intelligence. So that's the reason I've taken imlike, MLAI. Okay. So let me click OK. And these are all some other, this domain taken, this imlike.com, that's mine itself. But now the charge is, now it's pretty costly. It's 5,249 rupees. We might be able to help you get it. See how. Let me click how to get it. So here is how this works. You get a dedicated domain broker. When you purchase the service, a dedicated broker will help you formulate a strategy and budget to try to acquire your domain. So basically I have taken this domain now. So if somebody wants a similar kind of domain, so some dedicated domain broker will be allocated this work. So he will set up that meeting with the other person who is basically having this domain. So he will talk to the both, and he will create and he will come up with the final solution, and somehow you'll get it. The domain broker works the deal for you, and the domain is securely transferred to your account. That's how it works. If somebody wants my domain, so you have to just ask for add to cart, and so the domain broker will speak to me, and then if a deal is struck between me and domain broker, and domain broker will pay that money to me, and then it will securely transferred. The domain will be securely transferred to the new person, whoever wants that. However, this is my domain. Now it's costing 5,249 rupees, but before I purchased it at 139 rupees. That's fine. Okay. So now let me get back. So yeah, go back to the work. Yeah. So here you can see this is my, so just click my products, and here you could see account alert, keep you up to date, add SMS alert. That's fine. Okay, this is my domain. So I have my domain, so I don't need to create. If you do not have, kindly create your domain. So if I click on DNS, I have some existing naming servers. I'll delete all this. TTL, okay. So I have some existing naming servers, and okay, this 6 DNS records has been deleted, and I'll delete these also, so that when we are working on this, it would be pretty clear for you, or else you will get confused. So that's the reason I'm deleting the existing yeah, 5 new DNS records also has been deleted. So yeah, now I do not have any uh, yes, any DNS domain naming system records. Okay, nice. Yeah, DNS records. So these are all default one. Let's keep it. Okay, you've seen my DNS, and you should also get similar page for your domain if you have created, and you can click on manage to get into more information about your domain. So okay, just come here. This is all about your domain, forward domain, manage DNS, and if you click here and here, you will have your emails with imlike.com with your domain name. I think it's pretty clear now. So I hope you also created a domain name with this account. So let me mark up this. So the first one, that's open GoDaddy and create our domain. So the domain name should be remembered. It's imlike.com. So let me copy this and keep it in sticky note. This is what my domain is. Okay. So now, what's the next step? It's time to create our EC2 instance. Now let's log into our AWS account and we'll create an EC2 instance. So this is our AWS EC2 instance, AWS account, and this is our AWS console. And if you do not have AWS account, kindly create AWS account and then join with me in this session. So I will click on EC2 instance service. So this is Tokyo. I'm gonna go with US East 1, East 2, Ohio, and West 1, West 2. I'm gonna go with US West 2. That is Oregon. Yeah, here I'm gonna launch my EC2 instance. So just note down here, it's US West 2, that's Oregon. That's the region, and this is COPS. The name of the instance I'm gonna give is COPS. That's a KOPS, COPS. I'll go with Ubuntu 20.4, 20.04, and here I'm gonna give T2 medium, then key pair. I'll create a new key pair, so I'll say COPS key. Yeah, then network setting, I will go with the simple network settings, only SSH, nothing much. COPS SG and COPS SG. So this one, my IP, and rest all remains same. So let me launch this EC2 instance. By the time I'm gonna take, okay. So EC2 instance successfully initiated, it's been initiated. So now let me go to the downloads and take this cops.key and let me put it into create cluster. So this is where I'm gonna put my copskey.pm. So that's it. Let us check. By the time it gets and it's up and running, we will do other tasks. So this is done. The first step is done. Second step, AWS EC2 instance creation is also done. That to T2 medium. So now we are gonna create S3 bucket first and IAM user, then route 53 hosted zones. Okay. So let me, yeah, I'm here only. So now S3 bucket. Next one is S3 bucket scalable storage in the cloud. Let me click on S3 bucket service in AWS services. Now you can see that Amazon S3 store and retrieve any amount of data from anywhere. If you want to go through this, you can go through it so that you'll get a clear-cut understanding of what is S3 bucket. But for now, we will create our bucket. So name of the bucket I'm gonna give is V profile Charan cops state, because this is we profile this bucket where we will be using it to store the state of each object. So that's the reason the name we gave as a v profile Charan cops state. Okay, so we have created s3 bucket and we'll put it in US West, Oregon West, US West 2. Fantastic. You don't need to touch it. Region is also fine. And rest all you can keep it same or default settings. You don't need to attach anything else. Rest all will go with the default settings. Okay. Rest all fine. Let me create a bucket. So name of the bucket and region of the bucket are important for us. So now successfully created bucket. Bucket name is this v profile Charan cop state. Let me copy this. No, just name. I just want to copy this bucket. So put it in here. Yeah, this is our bucket name S3. Next, S3 bucket is done. Now it's time to create IAM user. So let me go to IAM services. Why do we require IAM user? So we want to access AWS, our AWS account from some other instance, some other machine. But how can you do that? So the only option is you have to create an user and then you have to give access to that user, and the security key, the access key should be stored in a machine from where you want to access this through AWS CLI. For that, you need to install AWS CLI in another machine, and there you have to provide the security keys of this user, so that from that, as a user, through your AWS CLI, you can access your Amazon Web Services account from a third machine or third party machine, or the machine which is not directly connected with the AWS. Okay, so now let's create a user. Let me click on users first. So we have IT admin, Terra admin. So now we are going to create a new user named cops admin. So the name I'm going to give is cops admin, KOPS. Let me make it small. Cops admin is the name. So enable console access optional. That's not, console access is not. For programmatic access, you can generate access keys after you create the user. So let me click next. Let me click attach policies directly, and what policy I'm gonna give is administrator access. So AWS access type programmatic access, and then permissions I'm gonna give administrator access. Rest all fine. Permissions boundary is not set. We'll keep it same, optional. Then we'll go one step ahead, and now you can see review and create administrator access tag is not required because we have attached a cops admin. Now let's create a user. So now it's creating a user. User has been created successfully. You can view and download user's password and email instructions for signing into the AWS management console. So let me either click here view user, or else we can click there. Yeah. So now here we can find out a security credentials. Okay. Let's enable console access, or else we'll directly create a create an access key. So access key best practice, that's okay. Let us directly create a CLI, command line interface access. Okay. And click next. And check I understand the above recommendation and want to proceed to create an access key. So key, the name I'm going to give is cops admin access and create access key. So it's been created and here is that, and you can download the .csv file from here. So cut and paste it in your directory. This is your file cops admin, and here you can see your access key and secret access key. So never access key and secret key. So never ever reveal this access key ID and secret access key to anybody. This is very secure and you have to keep it safe. I'm gonna delete this user from this, so that's the reason I'm basically showing it to you. However, I don't encourage you to share this with anybody, even with your friends. So now so the second activity is also done successfully. So now, so S3 bucket is done and IAM user is also done. So, and now the name of the is cops admin is the name of the user, IAM user. Now it's time to create route 53 hosted zone. Route 53 hosted zone. So for that, I will again route 53. Yeah, we can see that service route 53 hosted zone. Yes. Now we are gonna create hosted zone, and let me click on create hosted zone. So the domain name, this is the name of the domain that you want to route traffic for. So I'm gonna give kube vpro.imlaic.com. Yes, so that's what and it's a public hosted zone, and I'll give the same description. This is hosted zone for kube cluster. Rest all remains same. I'm not touching anything. So let's create a hosted zone now. So the hosted zone has been created. Let me close this. So 0 records. Cube whip pro, sorry, spelling is wrong. Let me delete this zone and create new zone. Create a hosted zone. This time at least I have to give proper one. Cube vipro dot imlaic.com. Rest all hosted zone for kube cluster. Create this hosted zone now. Yes, kubevipro.imlaic.com. Everything is fine. So here you can click for the hosted zone details, and these are 4 naming servers. These are 4 name servers that we have, and here you can see that kubevipro.imlaic.com. This is a routing, and these are the 4 naming server, and this is SOA, and this is simple one, like basically, and here this is not the naming server. Okay, so this is also done. So name of this hosted zone is kube vpro imlaic dot come. Okay. Now it's time to make a connection between Route 53 hosted zone, name servers and domain. So for that, what we have to do is we have to copy this. I'll copy all these four. Yeah. And I'll put it in our, yeah, here is fine. Yes. So now let's get back to our GoDaddy. Yeah, here it is. And yeah, this is my DNS. And let me click on DNS, or yeah, now you can see our DNS records. In this, I'm gonna add a new DNS record, domain naming state, domain naming server record. So choose an account. So I'm gonna go with NS, and this one I'm gonna exactly name. I will give Cube Wipro, and here the first one DNS. Let me get here the first, yeah, NS1, then TTL. I'm go with the default. I'm not gonna touch that. Okay, and so let's add this. Let's add this record. Update a DNS record imlike.com success. So you should find this here. So NS, yeah, NS Cube Pro, and fine. So now let's add one more record. Again NS name, yeah, and it's the second one. Default, I'll go with the default. Done. Next we will attach a third record. NS Cube Wipro, and default is absolutely fine. Let me, done. And the final record of naming servers NS and Cube Wipro, and paste the final naming server record, and TTL is default, and let's add record. That's it. All records has been added, and you can see that these are the four records has been attached. So now let's get into our sticky note. So the connection between Route 53 host zone and NS server domains, Route 53 host zone, NS servers and domain has been established. So now let's get into our hosted zone and refresh it. Yeah. So far we have done with domain, the first step, and the third step, and the fourth step. Now it's time to do this installation of COPS, kubectl, SSH keys, and AWS. These are the steps left. Let's do that. So for that, the steps follow like this. Let me go back to the AWS EC2 instance step. So here I'm gonna do. So first, once we log into the EC2 instance, then SSH keygen, we will generate that. Then we will install AWS CLI, then AWS configure, then once AWS configuration is done, then we will install kubectl and install kops. Once installation of all are done, then we will verify the domain and we'll create our cluster. That's it. Once all are done, next the fifth step is to create a cluster and verify our domain. That's it. Okay, let's begin our installations. Let's begin with SSH key gen. Now, but before that, we have to log into our system. Let's get into our AWS and then we'll see what's the condition of EC2 instance. So EC2, I should be in US West 2 region, Oregon. Yeah, it's a Tokyo. Let me change to US West 2. That's Oregon. Yes, here one instance is up and running. So let me click on that instance and click on connect and copy the SSH command and get into my directory where kops key is there and open a git bash there and then paste the command there and enter. So yep, we have successfully logged into the system. Now let's begin our activities. Okay, now pwd, yeah, it's a root directory, so snap. Other than that, nothing else. So here I am going to create my SSH keygen, SSH keygen, and execute. So generating public private RSA key pair, it's asking the file name. I will give kops SSH. So enter passphrase. I will give okay. That's it. Our SSH key has been generated, and this is the random art image that you can see here. And let me show you that. ls, you see that kops SSH and then kops SSH.pub. This is our public key and this is our private key. That's it. So now let's begin our installations one by one. The first installation we are going to do is AWS CLI, sudo apt update. Okay, you can see that US West 2, this instance belongs to. Yeah, all done. So now it's time to give, say, apt install AWS CLI option Y. So the installation process has been started and it's being installed. It's unpacking the package. So 95% is done. Let's wait for rest to be done. So but once installation is done, the next task is to configure this AWS CLI with our AWS user that we have created in AWS account, so that we can access our AWS account from this EC2 instance, from this kops server using sorry, this is not COPS server, this is just a COPS. From COPS machine we can access that AWS account. So let's give AWS configure. So it's asking AWS access key ID. So we have downloaded it. If you remember, here is that. This is our AWS access key ID. Let me copy this and paste it here. Now it's asking AWS secret access key. Again, let me copy this and paste it here. So now default region name, it's US. Let's confirm one more time. It's US West 2. Okay, US West. US West. Yeah, correct. Then default output format, I'll go with the JSON. And that's it. Configuration is successfully done. So now what's left? Let's install one by one. So before that, let's see the status. So SSH keygen AWS CLI installation is done. Configuration is also done. Now kubectl and COPS are left. For the kubectl, let's get into our documentation. Yeah, install and set up kubectl on Linux. Install kubectl binary with curl on Linux. So we have to download. This is common. This is only for Linux. You can use it, or you can just directly come here. Debian based distributions. This is a specific way of doing. But what we are going to do is we will use this directly. Curl, in spite of using packages, we will use the curl. This is far better. Download the latest release with the command. So we'll use this. Yeah. So get back and paste it here. kubectl AMD64 bin Linux, absolutely fine, stable version. Yeah, that's okay. So now it's being fetched, it's done. Now what we have to do is we have to give permissions to execute this binary file for all the users. So that's the reason I'm going to give +X, and the name of this is kubectl. That's done. Then let's move this kubectl binary file. You can find out here. You see that the kubectl, this file, and if we do lslrt, you could see that for the kubectl we have given execute permission for all. All means all. For the owner, for the group members, and for others. Everybody can execute kubectl. So now what I'm gonna do is I'm gonna move this kubectl file from root directory to the, that's a root user home directory, to the binary file, binary directory. So for that I'm putting to user, I'm going to put this into user local and then bin directory. That's it. It's been placed into the bin directory. You could see that no kubectl here. So now let's validate the installation of kubectl. For that I'm going to say kubectl help option. That's it. kubectl has been successfully installed, and you can see some of the commands. So all these commands we are going to use. Don't worry at all. Deploy commands, basic commands: create, expose, run, set, describe, delete, rollout, scale, everything we are going to see. So this is also done. Now install COPS. It's time to install COPS. Let me clear the screen first. to install kops. So again, we'll get into our documentation, and this time I'll say install kops, installing Kubernetes with kops. Creating a cluster, Linux. Yeah, so we'll go the Linux, not and at the end it's kops Linux AMD 64. Kops Linux AMD 64. This is the correct version. So we are going to take this kernel. Of course, you will have another ways of installing this using packages and all, but I would love to go with binary file. That's pretty easier than other ways. So Linux, because I don't, this could be, this can be used in any Linux distribution. So that's the reason I'm gonna do with this. So again, let me do curl, the binary file of kops AMD 64, and let me do ls. Yes, here you should see kops Linux AMD 64. Kops Linux AMD 64 binary file is absolutely visible. Now let me do ls lrt and kops Linux AMD 64. Nobody has execution rights, execution permissions, neither owner nor user, neither owner nor group members nor others. So now the first activity that we are going to do is chmod plus execute permission x and kops Linux AMD 64 and execute. And let's cross check that. And here it is. Execute, execute, execute. User, owner, group member, and others all has the execute permissions. Now let's shift this file from root home directory, root user home directory to the binary directory. So kops Linux AMD 64 and / user local bin and kops. Oh, sorry, not kubectl, it's kops. So this is where I want to move into the kops directory, and let me execute this. I think it's successfully moved. Yeah, no file here. So now I'm gonna validate the installation of kops. For that, I would say kops and help option. That's it. It's successfully installed, and you can see the available commands of kops create. This we use to create the cluster, a Kubernetes cluster, and delete to delete the cluster, and we have update to update the cluster, and version. Let's give the version kops version, and here it is, the client version 1.25.3. and now let's mark this. So installation of kops is also successful. Now it's time to create a first ever Kubernetes cluster. But before we create a Kubernetes cluster, we will verify our domain also. Okay, we'll verify our domain, whether it's been properly integrated with our AWS Route 53 hosted zone or not. That's what we're gonna do. Let's validate that. For that, I would say ns lookup, that is naming server lookup, and option is type. What type you have to look, that is ns naming servers. You look for naming servers, and it's a cube v pro, that's our hosted zone, that's what we have given, and imlaek.com. Correct? That's it. Here it is, server and cube non-authoritative answer, and you could find out that kubevipromlac.com has been connected, because this is mlac.com and this is naming servers. Properly it's been connected. Okay, so we are able to find out the information about this. So we have verified our domain. So this has shown all the 4 naming servers which are running in route 53 hosted zone. Okay, so now it's time to create our Kubernetes cluster. So let me clear the screen. It's a very big command. So cops create and cluster. Now name of the cluster equal to kube vpro dot domain. Kube vpro is subdomain and main domain is imlac.com. And state, where did we put the state? State is S3 bucket. Let's get into that and we'll copy that. Connect to EC2 instance and let me click on S3 bucket service. Let's bring it up. So yeah, I have this S3 bucket and let me click on this S3 bucket, and if you want to upload or download anything you can get it. And the properties and US West absolutely fine, and this is what we want. It's a V profile, S3 V profile cop state. Okay, let's copy this. Let me click on access point. Yeah, it's fine. The rest all it's okay. Yeah, state equal to, we are using S3 bucket and name of the bucket is this. I'll paste it here. Done. Then Jones US West. So I will go with US West. Okay, but before let me cross check what all that US West has. EC2 instance and global view. Yeah, we are in. Let me come down. US West, US West, US West, US East, US East. 1, 2, yeah, European Union, US West 2. Let me click on this. It has US West subgroups. So I'll use this Oregon. Yeah, here you should find zone name. You have US West 2A, 2B, 2C, 2D. Total we have 4. So I'm gonna use just US West 2A and 2B. That's more than enough. So US West 2A, comma US West 2B. That's it. And after that node, then we have a node count. How many nodes you want to have, that you have to mention. So node count. So I'm gonna have node count of 2. I will create a 2. Okay, 2 nodes. Cops is our main node and remaining two nodes are our working nodes. Okay, two nodes and size of the node size, that's a T3 medium, or T3 small is also absolutely fine, but that's okay. T3 medium, then DNS zone, this is very important, DNS zone. It's a DNS zone we have written. Let me copy that from here, or else whatever. From, yeah, this is S3 bucket. Yeah, this is our DNS zone. Cube vpro imlite.com. Yeah, it's I'll paste it. DNS zone name, done. Then node volume size. What's the volume you want to provide for your working nodes? Node volume size equals to 8 GB. Then master volume size, it's a master for a master node, so master node volume size, I'm gonna give, how much would be better, just let me think. I think for master volume size it would be 8 would be fine. It's okay, 8 16 also okay, but 8 would also be okay. That's it. So now we have to enter and see what's gonna happen. So if you go through the output, it's been printing on the screen. Okay, finally configure your cluster with cops update cluster name. Okay, so it's been the template has been created. Now we have to update this and then we have to validate that. So once the validation is done, so we could see. So we have to update the cluster. So it has, so now you could see that the cluster configuration has been created. That means a template has been created. Now suggestions, list clusters with cops, get cluster. I did this cluster, that's okay. And then edit your node instance. And so now finally configure your cluster with cops update cluster and the name S and admin. Of course, we have to provide the S3 bucket also. That's very important. Without providing the node, uh, without providing the S3 bucket information, you cannot store the state of the object. So that is the reason we have to provide. So now the template has been created. Now we need to update it. And then finally, when we say validate, everything will be created. So now let's update the template. So cops update cluster name option. So it's a cube vpro, it's on top. Let me copy this and paste it here. Then after that we have to attach the state, that is S3 bucket. State, we are using S3 bucket and it's a V, where is that? Okay, I might have, yeah, here it is. I copied some, yeah, V profile charan cop state, correct, exactly. So let me paste it here. Done. And let us say yes and admin, and let's execute. So cluster is gonna start issuing new certificate etcd peer CA events. If you remember the etcd, we have discussed about the etcd and what it does. So now here you can see clearly on the screen what the etcd is doing. Okay, cluster is starting. Now it should be ready in a few minutes. So suggestions from COPS, validate cluster. So COPS validate cluster, wait 10 minutes, and list nodes, kubectl get nodes. If you use these commands, you can do this kind of task. That's what the suggestions are doing. So now it's we have to wait for 15, at least 10 to 15 minutes to for the setup to happen. Okay, after 10 to 15 minutes we're gonna do COPS validate the cluster. So then let's wait for few more minutes and we'll get back to this. Yeah, now let's validate the cluster. So for that I'm gonna say COPS validate and cluster state, again S3 bucket, sorry, S3 bucket, and the name of that is, I'll just copy it exactly, I don't want to make any mistake, so I'll just copy and paste it. Yeah, that's it. Let's execute and see what's gonna happen. So using cluster from kubectl context, that's a kubevipro.mlac.com, that's our route 53 hosted zone. So validating cluster kubevipro.mlac.com, and here you could see master node, US node, a master node, and a working node, and a working node. So all are of T3 medium, and US West 2A, 2A, 2B, all has been the node status master node, working node. One master node and two working nodes have been created successfully. Your cluster kubevipro.mlac.com is up and running. It's ready to serve you. So now let's validate and look at Kubernetes cluster from kubectl, and we'll see what's going to happen. But before that, let's mark these things. Okay, all done, absolutely all done. Now, so let's validate this Kubernetes cluster from kubectl using kubectl. So let's do ls, and we have these files because we are in a root home directory or root user home directory. So I am gonna say cat, and I will give the absolute path tilde / dot, and it's a cube, and then inside that you will find the config file. So this config file is very important. This is called a kube config file, a Kubernetes config file, and this consists of a lot of information, but for us a few parameters are very much important. So this is the file which is mainly for the kubectl, but this file is used by kubectl to connect to the cluster. If you want to connect to the cluster from external instances or external server, even from your local machine, still you can do it, but you need to have this config file in your local machine. So that's why this is very important. That's a config file of kube. Okay, let's look into that one more time. Yeah, it starts here, and here it's mentioning the clusters. Cluster, the first cluster, the certificate has been given certificate authority data. Inside that you can see that the name that we have mentioned, the kubevpro.imlike.com. Absolutely, this is ours. And the domain that we have used, if you remember, HTTP, this is the complete URL of our server, and API, this is still that it's API, and after that kubevpro is subdomain and imlike.com is our main domain. And contexts, we have a cluster with this name and user with this name and name also with that name, and here you can see the usernames. You can attach more users if you want. So client, here they have given the client certificate data. That's all about this kube config file for now. So we are going to delve into this kube config file later, but for now this is more than enough. Then this is mainly used to connect to the cluster, the kubectl. If kubectl should connect to the cluster, that is only possible through this. And now let's give one more command. So kubectl get nodes. This is the first ever command that we are giving in this course. Till now we haven't typed any kubectl commands, and first time ever we are typing our command. So we have to celebrate this moment. Cheers for you and me and everybody who is following this course. Okay, I'm executing the first command in this kubectl get nodes. Cheers, guys. Yes, that's it. And this is the response. So total, how many nodes are running? 3 nodes. One is control plane, other one is node. These are two are working nodes, and this is a master node. This is a control plane. The cluster, we have created a cluster with one control plane and two working nodes, and age 7 minutes, 6 minutes, 6 minutes. Just recently we have created this. So now the next step, so we have done enough of validation inside our so validations of kubectl config file, and then kubectl command. Now we will done. So now we will validate directly in AWS console. Validate the cluster in AWS console. Okay, so let's get into the AWS console, and Oregon, let me click on EC2 instances. Okay, it's dashboard. Let me scroll up. We are in EC2 instances only, and let me refresh it. Here is the magic. Here is the magic. Cops that we have created, and remaining 3. Let me make it. Yeah. Fine. Node, master node. So master node is this, and working node these two. So all 3 instances have been successfully created by cops. So big congratulations to everybody, whoever is following and whoever is able to do this till now or thus far. So one more thing you should able to see here. So let me get it back. Let me get back to that. Yeah, here resources, auto scaling groups. Now you should see auto scaling groups also in addition to instances. What is this? So now this is created by auto scaling group. Whatever these 3 instances were created, those were created. It's not magical. It's a proper systematically happen things. So that was done by auto scaling groups. So if you come to auto scaling groups, you should see 3 auto scaling groups. Absolutely, you see that? So one for master. Let me make it. Yeah, this is master US West 2A, and other 2 for working nodes are workers. Okay, that's how. And this one is created by the AWS itself. Okay, so auto scaling group. So this step is also done. Now let's look into an VPC which was created by cops. So let me note down this. So these two were done. So next validation that we are gonna do is eighth one, that is looking into an VPC which was created by cops. Let's get into that. So I will type VPC, a virtual private cloud. I have clicked it on. Yeah. So now I'll click on your VPC. And here it is. Our VPC, that's a kubewipro.com. So we have created a virtual private cloud, and here you can find all the information. DHCP option set you can find out here, and here you could find out CIDR. We have discussed about all this terminology in networking module. If you haven't watched it, kindly you go there and watch it and come back here, because you will have a lot of fun there. So this is our CIDR. This is for IP version 6, and here you could see IP version 4 CIDR. We have clearly explained about this CIDR there. Kindly watch there. So main route table also you can see, and network ACL, and all the information that we can see here. So now let's go to the route 53 zone, and we will validate that also. But let me mark this. So this is also done. Now validating route 53 zone. Yes, here you could see DNS management. You have one hosted zone. Let me click on that one hosted zone. Yes, it is. Here it is. That's kubewipro.com. This is our hosted zone, which is public. It's a route 53 record count 5. Let me click on kubewipro.com, and you could see the complete information about that. Of course, we have seen this before, but few more important things you might have seen on this. Those are all three. Let me make it bigger, and here it is. See, we got three more servers which are included in route 53. One is API kubewipro.com. So route 53 in your hosted zone, you will see new records that are created API kubewipro.com. In this points to the master node IP. So then you have an internal that points to the master node private IP. This is the internal, it points to the master node, whereas this one API which points to the master node, whereas internal which points to the master node private IP. Okay, API master node, this is also master node, but this points to the private IP. You can see that here. You can see that 172 private IP, and the top one is public IP. This is basically our API server. Inside one component, that's an API server. And here you could see the COPS controller. This is not important for us because this is out of basically cluster. This is what our cluster. This is private, and this api.kubewipro.com, this is a public one. So now enough of validations. Now let's delete cluster. Let me get back to our server. Let me clear the screen. Okay, gone. Clear the screen. Yeah. So now let's delete the cluster. So how can you delete that? I would say cops help, and to delete, this is to update a cluster, this is to upgrade a Kubernetes cluster. Validate we have used, version we have used, export completion is here. It is create a resource by command line, and this is to delete. delete clusters, instance groups, instances, and secrets. Okay, so let's delete this. I'll say corpse and delete cluster, and name of the cluster equals to, we know that it's a cube wipro dot domain, that's imlayak.com, and state s3 bucket, that's what it's storing the state of our objects or of clusters. So that's let me copy this directly. Yeah, here it is. Yep, so that's it. Now let me say s and done. Error reading cluster information cluster.corps.kh. Oh, that's it. So that's the that's the issue when you type names of the cluster or s3 bucket. See, I missed out a zero O there, so it could not find that. So now it's gonna delete the cluster. It's deleting that. Not all resources deleted, waiting before re-attempting a deletion. That's okay. Volumes, DHCP options, route tables, subnets, completely virtual private cloud is going to be wiped off, and internet gateway. And let's wait for a few more minutes. Volumes are getting deleted. That's okay. So it's going to delete all of them, and it takes some time. Once the cluster is once the cluster is deleted, it's going to give it's going to give us back our shell. And never ever, do not try to delete this cluster manually, like when we were kids, when we were watching WWE. So that time they used to say, do not try this. So I am also saying, do not try to delete this cluster manually, because it's a lot. There are a lot of things are there. So if you really want to do it manually, then you have to start from auto scaling groups. First you have to delete auto scaling group, then you have to delete one by one all the services that we have used. Okay, that's it. Deleted kubectl config for kubewiproimlac.com. This is our cluster name. So the cluster has been deleted successfully. Now let's rerun the cluster. I'm just playing around. Okay, now let's rerun the cluster. So to rerun the cluster, now if we want to create it once again, it's just two commands, just two commands. So but most important aspect is the most important thing is, you should not remove your prerequisites. That means I'll show you that all those things should not be removed at all, like s3 bucket, IAM user, route 53 hosted zone. These things you should not touch it. If they're intact, that means you can recreate our cluster with two commands. Okay, the first command is corpse. Let's give the command directly, or I'll just volume is 8 and master volume is 8. Absolutely fine. Let me create this. Now the template is going to be created. Then we have to update the changes. We have to update it and we have to validate it. So that's it. Okay, error reading. What's the issue? Okay. S3 bucket, na? The issue is with S3 bucket. Okay, let me copy that. Let me check the S3 bucket. Okay, cops, maybe cop, some spelling mistake. vProfile cop states. Okay, I got it. I got it. I got it. I got it. The issue is here. Yeah. Anyway, I'll just paste it. State again. That's also one more issue. Yep. That's it. CIDR. Let's wait for that. Finally, configure your cluster with COPS update cluster. So let's update that. COPS update cluster and name. It's a cube vpro dot imlac. Okay, we'll keep this one and we will do the changes. Till state will it remains same, then adds a yes and admin. So rest all fine. So this is also okay. So here I'm gonna say cops update. Yeah. So the template is being updated and finally we to validate, then our cluster will be up and running. But before, yeah. So that's it. The cluster, it should be, the cluster is starting. Now the cluster is starting. Now after a few minutes it should be ready. So we have to say validate. So validate is nothing but we are just cross checking whether the cluster is started or not. So first one, when we say cops create, it will just create a template. It will make sure everything is done, all are available. And once we say cops update, then it's gonna create, it's gonna do actual action, it's gonna create those things. And when we say validate, and it's all done, it's cross checking, it's validation. So now let me say cops validate and cluster, and here name is not required. Let me give the state, that's S3. vProfile Charan and cops state. That's it. Let's see. I think it will take some time. Okay. Okay, it's taking some time. Let's wait. Cluster not at healthy. We have to wait for a few more seconds, a few more minutes maybe. That's it. Our cluster cube wipro.imlac.com is up and running. Let's validate it one more time. So EC2 instance, and here it is. We are in Tokyo. Let's go to the Oregon. That's US West 2, and you should see instances running, and we will go for all instances all. That's it. See, 3 instances were terminated because we have deleted the cluster. So those initial 3 were terminated, and now again master and then working notes again has been started back, and you can see the complete information about that. Okay, I think it's pretty clear for you. So we have seen enough. Now, what we're gonna do is, if you want to, if you want to continue with this with the next tutorial, you can simply leave this cluster up and running, or else you can delete this. You can delete this cluster saying cube saying cops delete command. Okay, but I hope you will follow me for the next session. So keep that cluster up and running. We will see you in another tutorial, that too specifically on Kubernetes objects and config files. Now the cluster has been successfully created. Now it's time to deploy and scale up our applications. So let's begin with our first exercise, and the name of this exercise is stateless application. It's a stateless application, and the application name is hello Kubernetes. And we are going to do deployment and expose this application to the external world using a load balancer. Okay, so here when I say deployment, I do not mean a deployment object. Okay, this when I say deployment in my slides in here, it doesn't mean a deployment object. It's a regular deployment that we do. So we are going to deploy an application and we will expose that to the load balancer. That's what the activity. So let's write the objective of this. And so objective main thing, we will run 5 instances of a hello world application, and we will create a service object that exposes an external IP address, and we will use this service object to access the running application. That's it. Use the service object to access the running application. Okay, so now let me put it in a proper way, in a Kubernetes way. First, what we are going to do is run 5 instances of a hello world application. So if we want to run 5 instances or 5 pods, that means this is a replica set object. A replica set object. Then we want to create a service object that exposes an external IP address. To do that, we need to go with the service object. A service object, we have 3 types of service objects, 3 types of services. One is node port, second one is cluster IP, and third one is load balancer. Okay, and the fourth one, using this service object, we should access the running application through the browser. That's what the fourth one is not the Kubernetes object. It's just a activity or activity. Okay, now if you think a replica set, so when we create a replica set, we are going to create pods also. That is the outcome of replica set. So here pod object, 5 pod objects will also be created. But do we use replica set to create or direct pod object? Which one we will use, which definition file we will use, that we will see. But for now, what I'm going to tell is, so to make this process simple, so objects, so definition files that we are using is one, deployment definition file, deployment object definition file. So when we use a deployment object definition file, in that definition file we have written in such a way that it's gonna create a replica object with with pod objects, 5 pod objects. That's it. We'll get 5 pod objects. That's the power of deployment object also, because if you want to do this activity, how can you do that? You have to first create a pod or replica, whatever you want, then you can go for the other. But you have to face some issues if you want to update, if you want to roll back, if you want to do some changes. That's not possible with the replica set object. So that's the reason what I'm doing is I'm using a deployment object definition file, and then inside that I'm mentioning replica set information and pod information. So once it is done, our pods will be up and running. Now it's pretty simple. So now we have to create a service object. And what type of service object? From definition file. But what kind of service object we want? We will go with load balancer for this example. But here what I am doing is, this service object I am creating not from definition file, not a declarative way. Service object through imperative way. From the command. Okay, or from the command. That's it. Now it's time to jump into the action or swing into the action. Okay, let me clear the screen. Okay, sudo option I, clear the screen. Now let me get into the root user home directory, and then defs directory and ls. So here I will create a folder called mkdir. So I am gonna create cops. So cd cops ls. Now let's create one more directory saying mkdir, name is hello kubernetes, hello cube. So now let me enter into the hello cube and do ls. Oh, nothing there. So now it's time to write our definition file. So the first step in this is to run a hello world application in our cluster, in our cops cluster. So let me take this. So the first step here is, so there's a steps now, steps that we're going to execute. The first one is to create a deployment definition file and create deployment object. Okay, let's do this first. pwd, yeah, fine. We are inside the hello cube. Now let's write the name of that. So it's vim and load, and this is I'll name it as vim hello cube dot aml. So let's write our load balancer definition file. So what will we do? We'll do the same. We will get into our VS Code and we will write it there and we'll copy paste it here. So now let me get into that cops directory. Inside that I will create a folder called hello cube, and inside this I'm gonna open my VS Code. Okay, so let me close this. Click on new file. The name I'm gonna give is load. This one is hello cube dot sorry, hello cube def dot, it's hello cube deployment definition file. So that's why I'll say hello cube dep YAML file. Okay, let's begin writing our deployment object definition file. So let me say kind and get the template of deployment object. Yeah, I got it. Now let me remove this. Yeah, API version apps v1 kind is deployment. Metadata name I'm gonna give as hello cube and labels I'm gonna attach labels. So I would say app. Yeah, for app, and I would say hello cube app would be better. Yeah, done. So now spec, let's come to the spec. In spec, how many we have replicas? First let me look into the replicas. So here I do not have the replicas, so first let me put the replicas here inside the spec. I want a replicas. I want 5 replicas because I'm using a replica set object here. So replicas 5. Then after that I have selector basically to match with other object. So here I'm gonna mention in match labels app, and then I'd say match labels app, and the name of that app is cube app. Done. Then after that we have template. In template we have to provide the metadata, and metadata label is again app, it's a cube app. Done. So now it's time to attach the image, attach the information about the container inside the spec. So name of the container I'm gonna give is hello cube, and image I'm gonna get it from GCR, that's Google Container Registry, gcr.io / Google samples / node hello. So node hello, and tag is 1.4 that I'm gonna use it. And once the image has been given, now it's time to map the ports. So I do not require these resources. I'm gonna remove this. Yeah, yes, port is in same indentation as image, absolutely fine. So the container port I'm gonna go with 8080, and after this at this port I'm gonna attach our load balancer. Okay, let me cross check one more time. API version is fine, and kind, it's a deployment object definition file. Metadata, I put hello cube inside the label app cube app, and in spec replicas in selector I have matched these labels with the top label match labels, and then template I gave the same app, and then container, let me cross check this image GCR IO Google samples node hello tag 1.4, absolutely fine. Let me copy this first and get into our cops machine. Cops and ls vim hello cube, and what's this? Let me say I remove all those things, information, or else let me say percentage D modifiable is off. So RM RF. So Vim hello cube dot ml and paste the respective code of object file. So let me do wq save and quit, and let me do ls, and here is our definition file, a deployment definition file, which gonna create this when this deployment definition file can create two objects in turn. One is three objects. One is deployment object, and then a replica set object, and finally it will create a pod object. How many pod objects? 5. Let's look into that. So let's apply the changes. So let's create the object. So kubectl, then apply or create. Apply is advanced command, and then file name is hello cube.aml. That's it. Deployment.apps and hello cube has been created. If you think only one object will be created, that is foolishness. So what I'm gonna do is I'll say kubectl and get all, and you should see all. We got a service. This is existing one. This is not belongs to us. You created a deployment dot apps. It's a hello cube deployment object, and you have created a replica set dot apps, and here you should see hello cube replica set object. So now kubectl get pod, and here you should see all the pods, 5 pods which are up and running, because we have gone with the replica set of what replicas. How many we gave? I'll show you. So we gave 5. So that's the reason 5 pods has been created. So with one deployment definition file, we have created a deployment object which is hello cube. We have created a replica set object which is hello cube with random number, and then we have created 5 pod objects. Now let's get into the deployment object. So let me say kubectl get deploy. So this is our deployment object. 5 ready, 5 update, 5 available. Okay, so up to date, 5 are up to date, and 5 is available. Current state to desired state, everything is satisfied just 95 seconds ago. Even our pods were created just 47 seconds ago. Now let me clear the screen and say this time what I'm going to say is kubectl get all. So this is what I want to prove. So with one deployment object definition file, you have created an object, you have created a pod object, you have created a deployment object, and you have created a replica set object. So that's the power of deployment definition file. Of course, you can do more than that. You can do a lot of activities, such as you can update, you can change, you can roll back, so roll out, a lot of things you can do. That's the other benefits of deployment. Okay, so let me also do kubectl describe and what we have here is deployment. I want to describe deployment, and name of the deployment is hello cube, and this is the information about the deployment. So normal scaling replica set, it took age is 3 minutes 2 seconds, and deployment controller has came into the action, has come into the action. So here you should see the information about the replica sets. We haven't done any rollouts, so that's the reason we have only one replica set. That's a new replica set. Old replica set is not there at all. Then we have image, the image that we have used, and port mapping is here, and mounts we haven't used, and here you have the more information about that. Labels, you see that the label that we have used is app equals to cube app. Annotations, selector, again app is equals to cube app. Replicas 5 desired, we have asked for the 5, and 5 updated, and 5 total we have 5 are available at this moment. That's enough. So rolling update strategy, 25% is maximum unavailable, 25% is maximum search. At any time 25% can only be unavailable. That's the rolling update strategy when you are doing rolling updates. Okay. At any remaining 75% is always available when you are doing rolling updates, from changing from new to old, from new update to old update. 25 while changing, 25% will only be unavailable, rest all will be available. Okay. For example, you have 100 pods. When you are rolling out to the new pods with the new update, then what's going to happen is, while you are changing, it may take 5 to 10 minutes or 15 minutes, sometimes it may take 20 minutes. While changing, only initially 25% will be changed, remaining 75 pods will be up and running. And after that, at any time while rolling out, at least 75% will be available, 75% spots will be available, so that your app will up always. Okay, so now it's time to, so enough of deployment. We have seen the deployment, we have described the deployment. Now after that, we have seen we will also see kubectl get rs replica sets. You see that this is our replica set. We have desired for 5, and current we have 5, and ready 5. Then if you want to describe it, you can describe this also, kubectl describe, and it is a replica set. I will say rs, and name is too much. I'm gonna copy it. And here it is. So normal, success, total 5 na. So 5 pods were created using this replica set, and you can see the each and every pod name. And image, rest all remains same. It's not completely different. So now I'm gonna say kubectl get pod, and you should see the same exactly these 5 pods and these 5 pods. Okay, and if you want to see each and every pod, you can also describe the pod. That's not a big deal. But what we're gonna do is, we have to create a service object. Okay, the first step in this is done. That's create a deployment definition file and execute it. Okay, and create a deployment object. So while we have created this deployment object, how many objects were created? How many objects were created? 1. It is pod. 5 pods were created. 2. A replica set object was created. 3. A deployment object was created. That's it. Now the second step is to create a service object that exposes the deployment to the outside network. Imperatively, I will use imperative method. So imperative method for now. Okay, let's do that now. So what I'm going to do is, as it's imperative method, so I will say kubectl. For that, I have to say expose. What do you want to expose? I want to expose a deployment. And name of the deployment is hello cube. And what type of service you want to have? We have three tabs: node port, load balancer, and cluster IP. I'm going to go with load balancer. It's an environment variable. You have to make sure you have given correctly. Capital L load, and after that capital V, capital B balancer. Okay, it's fine. Rest all fine. So now I have to give few more options. Name. So what name you want to provide this? I'm gonna say this is my I'm gonna say it's cube service. Okay, cube service. Let me click enter. That's it. Your service or cube service has been exposed. Now let's see services. So to see the services, to display information about the service, you have to say kubectl get svc. Okay, you have two services. One is cluster IP type service, which is default one, you don't need to touch it, and the other one is the service that we have created. It's a cube service, and the type is load balancer, and cluster IP is this, and external IP it's still waiting for something. Let's see. So now what will we do is, let's get into our AWS and we will see whether any cluster any load balancer has been created or not. So now let me come here, Amazon Web Services. Yeah, let me refresh it. Yeah, this one. That's it. It's been created. So load balancer is started. It's been put into action. So let me click here for more information. So now we are inside the load balancer dashboard. So zero, the health checkup is still taking place. Once health checkup is done, it's gonna start two instances. You could see the status zero of zero instances in service. So it hasn't been started. So now let me get into the instances. Okay, it has selected two availability zones: US West 2B, US West 2A, and subnet IDs, and but it hasn't started any instance. It's doing health check. So let's look into the health check. This is the information. Ping target is this, and timeout. So listeners, so this is gonna the load balancer port. This is 8080 is load balancer port. This will be listening to the instance port at 30,088. So this here we'll get the monitoring information, and let's wait for that. And tags. So we have default kube service at this, and Kubernetes cluster we are using kubewipro.mlac.com, and it's owned by this guy. Okay, so let's, and final one is migration. It's not required. Let me get back to the description and let me see the status. Nothing. And here also you can see the port configuration, 8080 TCP. To forwarding this, our load balancer will forward the request to 30,088 TCP. So at this port, whichever pod are listening to that port, that will be accessed, and inside that pod, the container will also be accessed. So let me refresh it. Okay, one of two instances in service. Let me get here. So one is in service, which is this one, and you can see that nodes US West 2A kubewipro.imlag.com. Other one is out of service. It will take some time. I'll show that instances so that you'll get more clarity that these were created in our instances only. You see that nodes. Okay, so these are the two. You see that these are the two nodes, US West 2A and US West 2B, kubewipro.imlag.com. Correct? These are the two instances which are part of our Kubernetes cluster. These are the two nodes which are part of our Kubernetes cluster, and here you could see in that two nodes, two instances has been created. So let me refresh it. Okay, so now two of two instances in service, they are up and running, no issue at all. You can see that two instances are in service. So now it's time to get back to our cops machine, and let me give kubectl get svc, and here it is. You see that before it was pending external ip, now you could see the external ip here. Okay, and this is our external ip, and this is the port mapping 8080 with 30,088 internal. So this is what, where this is the IP we have to get it, and this is the port we have to take. But not from here. I will take from the Amazon Web Services only. Just you can come here to the load balancer. You see that DNS name. You click on this icon, copy icon, and let's paste it here. And 8080. That's it. Let me zoom it. Hello, Kubernetes. That's it. Deployment, a proper way of deployment, and exposing this to the outside network using the Kubernetes object. Proper Kubernetes objects. Let me show you. Let me mark this also. So this is also done. And then the third one, validation, is also done. So here we have used service object. So pod object, replica set object, deployment object, service object. These are the main objects of Kubernetes. We have used all to deploy a simple Kubernetes, hello Kubernetes application. So before we look into the other aspects, I just want to tell you one more thing. Many of the people may face some issues when dealing with your load balancer. Sometimes your load balancer may not come up even for the long time. In that case, the problem could be, see, this is the elastic load balancing uh, user guide. So you can go through this. The problem could be you might not have this AWS service role for elastic load balancing. If you do not have this elastic load balancing, what you can do is, by when you create, by default it should be created by the AWS. If it is not, then you have to create that. So, or else you manually create one load balancer in your AWS account. If you manually create a load balancer, one load balancer, then obviously this AWS service role for elastic load balancing will be created. Then after that, when you want to create it from the cops, from the Kubernetes cluster, it will work. Okay, so you can see that you don't need to manually create the AWS service role for elastic load balancing role. Elastic load balancing creates this role for you when you create a load balancer or a target group. Okay, so I will show you my, you see that Amazon service role for elastic load balancing. This is what you require to have. So let me refresh it. Yeah, see, I have some roles. I have attached some roles. By def, I have attached this also, like EC2 role, AWS service EC2 role using kubewipro masters and nodes. And then this is by default, it will be attached. In addition to that, you could see that service linked role, service linked role, service linked role. So this service linked roles will be attached when you try to create your load balancer or respective service. If it doesn't happen, you manually create one load balancer or one service, or else you can manually create that service itself. So here you can see that this is what I'm talking about. AWS service role for elastic load balancing. Okay. So or else you can click on create role, say AWS service, and then here I have used this EC2 instance. I have used this EC2 also. You want specifically for what you want, elastic load balancing. Here it is. You just click elastic load balancing, you check mark this, and then click next, and then yes, you'll get it, this AWS elastic load balancing, and then you click on next again. So here it's saying allow it ELB elastic load balancing, sorry, allows elastic load balancer to call AWS services on behalf of you. Absolutely, that's what I want. Either you can copy this exactly and go to the, let me come here, and let me open this on a new tab, and once your cloud shell is up and running, you just paste this. So once it's running, you take that and you paste it and you execute that. So that also works. So after that, once you have selected that, you can click on create a role. So a role with this name already exists. That's why I cannot create it again. But that's how you can create. If you get that problem, most of the people will face this issue. So that's the reason I'm specifically mentioning, I'm specifically explaining how to solve that problem. Okay, so now let's get back into our exercise. Okay, so now what I'm going to do is so we are successfully accessing this. You can see that I'll refresh it. Yes, still it's up and running. So now let's look into that cubes. Okay, sudo option I a, yeah. Okay, so now let me say kubectl get services and hello, what's the name of our service? Hello cube, huh? Okay, kubectl get svc, the name of our cube service, sorry. So cube service, so we want to get only our service. Let me say kubectl get svc hello, sorry, cube service, it's on top, cube service. Yeah, you see that this is only our service, cube service, load balancer and external IP and port mapping, and 12 minutes ago. That's it. So type load balancer service is backed by external cloud provider, that is our AWS, Amazon Web Services. Now let's display detailed information about the service. So what I'm going to do is kubectl describe, and it is services or svc, and name of our service is cube, sorry, cube service. Okay, initially we face some issue, it's unable to connect with our load balancer. This kind of error you may also get it. You see that, the problem here, service controller error syncing load balancer, failed to ensure load balancer, unable to update load balancer attributes during the attribute sync, access denied. So if you get this kind of error, because no identity policy allows the elastic load balancing, you see that this part, elastic load balancing on. So if you face this kind of issue, then you follow that, you do that. Okay, then you can see that load balancer is normal. So 10 minutes ago, service controller and ensuring load balancer, absolutely fine, no issue at all, it's working well. Let me scroll up, and here you could see complete endpoint, a complete endpoint. So we have two more endpoints, however because these are all connected through the Amazon Web Services load balancer. You can see name of the service, kube service, namespace is default by, and then labels, and type is load balancer, a single stack family IP, and load balancer ingress is here. So this is our load balancer ingress. Directly you can copy this and use this to basically access our application, and 8080, that's the port, and target port is this, and node port is this 30,088. By default it will take, we don't need to give it specifically, and endpoints and external traffic cluster. That's it. That's all about this exercise. So now what we're gonna do is we will delete the respective, will clean up, okay. But before we clean up, I'm gonna get into the pods. We'll see the pod. Get kubectl get pods, or, and I want wide information, more information output equals to wide. That's the option I have used, and here are all the pods. All 5 pods are up and running. So what I will do, just to have some fun, I'm gonna delete a few pods first. Okay, I'm gonna delete few pods and we'll see what's gonna happen. You can see that all 5 pods are on top. I will delete these 2 pods. So kubectl delete pod, and I'll give the name of the pod. This is 1. Paste it, and this is 2. We will delete 2 pods and give a space and paste it here, and let me execute it. See, 2 pods has been deleted. kubectl get pod, but still 5 pods are running. So these 2 are terminating, still under terminating status. 25 minutes, 25 minutes. In space, in spite of those two, in place of those two more pods are started. One is 16 seconds, other one is also 16 seconds. You see that? 16 seconds, 16 seconds, and remaining all are 25. That's the power of replica. Basically, how we are able to achieve this? Using a deployment definition file, using a deployment object. So we have to thank deployment object for that. Okay, so after thanking the deployment object, we will do one more activity, that is we want to use the external IP address, the load balancer ingress, and to see, because we have taken this load balancer ingress from AWS, and we have seen in describing the service, but there is a one more way to get it. That is, you can say curl, and so now it's time to clean up our cops machine. So let's delete the service, and we'll begin with the service. We will delete the service first. To delete the service, we have to say kubectl. Okay, what the issue? Let me clear the screen. Kubectl and delete services, and name of the service is kube service. So the service has been deleted. So the service has been deleted. Still kubectl get pod, sorry, not get pod, get all objects. You have okay, the service hasn't been deleted. It will take a few more minutes. Let's wait for that. Yeah, now it's been deleted. You see that here? No service, only cluster IP service is there. I'll show it. Yeah, So now the pods are still there, pods are up and running, and you have services which is cluster IP. This is default one. Our service has been deleted, and deployment object is still there, hello cube, and replica set is still there. So we have a pod object, we have a deployment object, we have replica set object, we do not have a service object. Can we access this application? Yeah, I'm asking you only. Can we access this application without service? Let's see that. So this is our application. I will refresh it. That's it. Gone. That's what happens. Service is very important. Without service, you can't do anything. So that's why. So with this, you should able to get. You should understand that a service is the one which makes your application to expose to the outside network. If that is not there, you cannot do anything. So each object is very important. So as we do not have a service, we can't basically expose it to the external outside network. So now we will delete all other objects also. We will begin with first we will delete replica, or we'll just delete the deployment. Rest all will fall in place. So kubectl delete, this is deployment, then name of this is hello cube. Okay, that's it. Deployment.apps hello cube is deleted. Now let me take few seconds to look into other objects whether they got deleted or not. Okay, let's wait for some time because it may take some time. Let me say kubectl get all. Okay, these are getting terminated, and your service, okay, your replica set is gone, and these are getting terminated. Let's wait for a few more seconds and execute the same. Let me clear the screen and let me say kubectl get all. That's it, all gone. The default service is left, and then job that I have created 44 hours before is left. Rest all deleted because we have deleted the deployment object, and replica set and pods. Pods are dependent on a replica set, and replica set is dependent on deployment in this definition file. So that's why with removal of deployment object, all got deleted. So with this, we have successfully demonstrated the objectives that we have discussed earlier, that is running 5 instances of a hello world application using replica set object and then pod object, and then we have created a service object that exposes an external IP address using service object, and we have used the service object to access the running application, and we have accessed it through our browser. Now it's time to say goodbye to this exercise, and we will meet in another exercise.